These are your instructions. In general, you just need to follow the PowerPoint. There are instructions for you in the yellow boxes on each slide. Please make sure the sound is turned up on your device so you can hear the narration. And remember, if a slide asks for homework, don't forget to send it via Show My Homework. If a slide asks for Educate to be completed, don't forget to do it by the date that's given on the slide. This lesson is the first on a series of lessons about density. And today's objectives are to recall how to measure mass and volume, to calculate the volume of regular shapes. We want to learn a method for finding the volume of irregular shapes, and then learn a definition for density. Have a look at these two bricks. They're both physically the same size, but one is obviously more dense than the other. But what do we mean when we say something is more dense? What is density? In physics, density is a property of materials. It is the amount of mass in a volume. Basically, it is telling us how tightly matter is packed together. Materials that are more dense have more mass in the same volume. In this diagram, the cubes are the same size, but the one on the right has a lot more particles squashed into the same volume, so its density is greater. You can make an object more dense by keeping the same number of particles but decreasing the volume. This is what happens when we compress a gas. The particles get squashed closer together, and that is increasing the density. The density of a material affects lots of its physical properties. One of the most important is whether or not it will float. Materials that are less dense than water will float in water. Materials that are more dense than water will sink. This is an experiment you can do at home using a can of full-fat Coke and a can of Diet Coke. If you put them both into water, one will float and one will sink. It turns out that the extra sugar dissolved in the can of Coca-Cola makes it slightly more dense. So the full fat one will sink and the Diet Coke one will float, despite the fact that there's the same amount of liquid in both and both cans are the same size. You can work out density using this formula. To use it, you need to know two things. You need to know the mass of something and you need to know the volume. Once you know those two things, you can work out the density by dividing the mass by the volume. Density is often represented by this symbol. It looks like a P, but it's actually the Greek letter rho. So if we know the mass and the volume, we can work out density. But it's also important to remember that as long as we know two of these things, we can work out the other just by rearranging the formula. So here, if we know the mass and the density, we can work out the volume. If we know the density and the volume, we can work out the mass. If you're not happy rearranging the formula, you can use a formula triangle like this. So if you look, this is our original formula, density equals mass divided by volume, and you fit this into the triangle, density equals mass divided by volume. And then whichever item you're trying to work out, you just cover up with your finger that item. So if I was trying to find out density, it'd be mass divided by volume. If I was trying to find out the volume, it'd be mass divided by density. And if I was trying to find out mass, it would be density times volume. To work out density, we need to know the mass and the volume. Mass is relatively easy to measure, and you've had plenty of experience of doing this in the lab. Mass is the amount of matter that there is in an object. We yet measure it using a mass balance. The unit of mass is the kilogram, but to measure small masses, we can use the gram. There are 1,000 grams in a kilogram. You can also use a mass balance to measure the mass of a liquid. The only thing you have to be careful about is not to include the mass of the measuring cylinder. So in this case, you set up the mass balance, zero it, put the measuring cylinder on the balance and zero it again, and then add the liquid and record the mass. Once you've measured the mass, it's time to measure the volume. For regular solid objects, this is relatively easy. Have a look at this picture here. If each of those squares is 1 centimetre, how would you work out the volume of the shape? Stop the recording here while you have a think. With regular solid objects, finding the volume is quite easy. You just have to multiply all 3 dimensions together. So if you have a look at this picture, you have to multiply the length by the width times the height. So in this case, it would be 2 times 2 times 2. So that would make it 8 centimeters cubed. Let's see if we can use the same method to work out the volumes of these shapes. So the first one is 3 by 1 by 3, which gives us a volume of 9 centimeters cubed. The second one is 3 by 2 by 2, which gives us a volume of 12 centimeters cubed. And the third one is 3 by 3 by 2. And if you multiply those together, you get 24 centimeters cubed. Stop the recording here and make sure you can work out how we got to all of these figures. Pause the recording here and see if you can work out the volumes of these shapes. Bear in mind that each square is 1 centimetre long. Check your answers using this information and green pen them if needed. Pause the recording here and see if you can work out the volumes of these shapes. Bear in mind that each square this time is only 1 millimetre long. Green pen your answers using this information. Make sure you've got the other units right. So, measuring the volume of a regular object is pretty easy. But what if the object is not regular? What if it's an odd shape? Well, this is a method we can use. It uses a piece of equipment called a Eureka can and a measuring cylinder. What you do is you fill the Eureka can with water up to a level of this spout, and then you let it settle. Once it has settled, you drop your object into the water. The level of the water rises, some of it comes out of the spout, and you measure it in this measuring cylinder. The amount of water that's displaced into the measuring cylinder is the same as the volume of your submerged object. So you can just read it off the side of the measuring cylinder here. Now, unfortunately, this method will only work if your object sinks in water. If it floats, it won't displace the correct amount of liquid. Finally, just a quick note on measuring the volume of liquids. Obviously, we measure them using a measuring cylinder, but if you look closely at the level of your liquid, you'll see that it doesn't go straight across. It's higher at the sides where the liquid meets the measuring cylinder. This is because of something called surface tension. When you're measuring it, you need to measure here at the bottom of this curve. This curve is called a meniscus, and you measure across the bottom of it here to make sure you get an accurate reading. Measuring cylinders are graduated in millilitres, and each millilitre has a volume of 1 centimetre cubed. This is your homework for this lesson. Answer these 4 questions and send your answers in to Mr. Rahman via Show My Homework by Wednesday the 29th.